In this interview, we're going to explain how CodePen gets 32 million page views a month. Hey fellow coders, today I have the pleasure of interviewing Mr. Tim Sabat. Tim is a co-founder of CodePen. He handles all their backend services, so I wanted to get him on the show to talk about that. If you don't know what CodePen is, which I would be very surprised if you don't, but if you don't, I think you should pause this video right now and go take a look at it. Frankly, it's an incredible service. I've used it too many times. It's used by millions of designers and developers to test out concepts and share code snippets and that sort of thing. So if you don't know what it is, pause this video right now, take a look at it, and then come right back, because in this interview, we're going to be talking about their infrastructure, how they're able to handle 32 million page views a month, 3.2 million uniques a month, between 5,000 and 12,000 requests per minute, and about 80 to 200 per second. These are incredible stats, and I want to look at their entire infrastructure and then peel off the different layers so we can understand what they're doing right and how we can reproduce this with our own servers and services. Tim, thank you so much for being on the show today.
Thanks for having me.
Yeah, it's great to have you here. And you know what? It's funny, I actually emailed Chris Coyer for an interview because I've been doing a lot more back end on the show, and I kind of want to get some front end people to talk about the different JavaScript aspects of performance and things like that. But he said, you know what, man, I'm traveling so much the next few months, but check out Tim Sabat. He's our back end guy. I really think he'll be a good fit for the show. And I looked you up, and man, I couldn't believe it. Perfect for the show. You've talked a lot about, or you've blogged a lot about Chef and Docker and Amazon Web Services and things like that, which is what we talk a lot about on the show. So it's really good to have you here. But for people that don't really know who you are, maybe they haven't seen your work yet, can you walk us through some of your previous work with different companies and where you come from?
Sure, yeah. I don't know. My background is kind of I've been involved with computing in some way since I was a kid. My dad went to MIT, he worked for IBM, and we always had a computer in the house. Mm-hmm. I went to school for MIS, which is like a business degree, but with a computer science focus. Okay. And when I was there, I did a lot of programming courses because the business aspect kind of bored me a lot, and the computer parts were really cool. And in those classes, I met all my friends and ultimately my business partners. They're at University of South Florida. Okay. I began my life at the VA. I worked in Java and .NET, and I wrote in a language that the VA still uses called MUMPS. It's the Massachusetts General Hospital Utility Multi-Programming System. It's like it's this crazy language. All right, it's an ACID NoSQL database. The language and the DB are kind of married together, and it's like got some really crazy constraints. The thing was written in the 70s. The variables are all global; they're namespaced. And you have an 8-byte maximum for variable and method names. And what's crazy is the first 3 characters represented the application itself. So, like your maximum variable name, once you got your namespace out of the way, was 5 characters long. It's this insane language. But they were trying to bring young people into the VA, and they were doing a lot of rewriting into Java and .NET, and they hired me out of college to do that stuff. At probably the most important thing that came out of that is I met my co-founder of CodePen there. Okay. His name is Alex Vasquez, and he does all of our front end and a lot of the Ruby work. And so out of that, I learned what I didn't like, which is Java and .NET. And
you and me both.
I learned what I did like, which was, my buddy Alex, who's worked with me like truly for the last, 10 years or something like that on almost every project we've ever worked on. Wow. During that time, my buddy Ryan Campbell had started this company called Wufoo. It was a YC-baked company. And after about 2 years of him working on his startup, I just kept bugging him, like, look, man, I'd really like to work with you guys. And ultimately that worked out. He contacted me and was like, yeah, I'd like you to come on. And I'm like, well, I want to come in, but I also want to bring my buddy Alex. And although they didn't necessarily have the budget for it, at the time they brought him on, and it was a super great fit. So I worked for Wufoo for 3 years before we were sold to
Okay.
SurveyMonkey. Wufoo is a PHP and MySQL shop. We use no framework, just straight up I don't know, code muscle, and we banged our way through it.
This was 8 years ago, you said?
Well, so Wufoo started 8 years ago.
Okay.
I was on board after the first 2 years of inception. So that, yeah, you rewind the clock like 7 years or so, and that's started there.
Yes.
Worked there for 3 years.
So back then there really weren't that many frameworks anyway, right? I mean,
No, I think Cake PHP possibly was a thing at the time. But yeah, mostly we used an HT-access file for routing, and we had like a kind of controller type thing where when we came in, I sort of moved us a little bit towards like software services basically, but not services in the infrastructure aspect,
Okay.
more like just services as in like service objects. And we built up Wufoo. That was a strong sale. We sold to SurveyMonkey, and
Awesome.
I worked there for another 2 years, where I kind of wore called the golden shackles or whatever. I loved SurveyMonkey. I loved working there, but it was a big company, and I really enjoyed doing startups. So for 2 years, I worked there while we were kind of like completing our contract.
Sure. Okay.
While I was there, I like completely fell in love with ops, though. Like I loved Wufoo and I loved what we did there, but one of the kind of downsides I found is that we knew nothing about ops at all. We outsourced to a company called BitPusher, all the server, like basically anything having to do with servers. We would write PHP code and we would toss it over a wall, and somehow, that stuff ended up on servers or being stored in databases, and that I felt that was a bit of a blank in my knowledge, and it was something I felt like I had to learn. And so while I was at SurveyMonkey, I tried to position myself as closely as possible to operations. So we had sort of a DevOps team there, and that's where I cut my teeth on Chef and Vagrant, and basically just did everything I could to learn and understand ops. Switched my editor to Vim, committed to it completely, and I've never looked back. It's been it's kind of like where I enjoy spending the time. I like working on application code because I know, for me, that's where the money's at. That's how we make a living, by writing
Right.
application code, not by writing infrastructure code. But when I get the opportunity to do operational stuff, which I would say is, depending on the time, can range from like 25 to 50% of my time, that's probably where I prefer working the most.
And see, you started out using things like Chef and Vagrant and all those that I still use to this day. I rely on Vagrant every single day. I use Capistrano to deploy. I've done some work with Chef as well, and we've actually interviewed Nathan Harvey of the Chef team a few episodes back, and we talked about that. But today you don't really use those as much. So that's why I'm so excited to have you on the show, because I want to talk about the differences, what made you switch, and why you're using different things today. So we're going to talk about that a little bit later, but I want to stick to, so you were at SurveyMonkey. Is that when you met Chris Coyier and started working on CodePen?
So Chris Coyier was hired by Wufoo originally, so he had worked for Wufoo for about a year before we sold to SurveyMonkey.
I gotcha. Okay.
But during that time, we sold to SurveyMonkey, and at the time it was a little maybe off-putting to suddenly be told, "Hi, you live in Florida, you have a wife and an unborn child, and we're going to pick you up and we're going to just move you to a different place." And
Wow.
while it was exciting, it was also a little bit scary.
Yeah.
And at the time, I said to Alex and Chris, I'm like, we need to do something. We need to do a startup so we have a little more control over this uprooting factor in our life. Like, I want to be able to. I want to have a little more control over my destiny. And we didn't know what we wanted to do, but we all agreed, like, during that sale process, that we need to be in the driver's seat next time. Like, we can't, we can't let someone else control our destiny. So at the time, a year went by at SurveyMonkey before we really got started on any real project. We did a couple kick around projects, but it wasn't until a year later that we honed in on this idea of CodePen.
And let's see, are you guys using AWS? Did you start out using AWS at first, or did you transition to using Amazon Web Services later on down the road?
we were with Rackspace for like half a second, but we were on their free tier, and like I don't know, I wasn't even responsible for that at the time. Like Alex had set up a server, and like he had read somewhere about Capistrano, and we got something published, but it wasn't until we weren't live yet, and from the very moment we started CodePen, we were on AWS. The only time we've spent elsewhere was like in pre-conception days, and those I wasn't really involved with that. It was AWS from the beginning.
So when you started CodePen, did you already know it would be a big service or big product, and you built the infrastructure for that, or was it just some kind of project and you thought, well, we think this is going to take off, we think this is a good idea, and we'll get some good traction? What was your mindset back in the day?
Back in the day, our mindset was, this is a pet project. This is we don't really necessarily know whether it's going to take off at all. We built it with no concept of scaling. We put literally everything on one server, database, application server, caching, the whole thing. Like it was just, and there's nothing wrong with that. That's just like the mindset at the time was like, hey, we're just throwing up this project for Chris. It started as a weekend project. We had a live version of it within a month, and we didn't anticipate it being a big thing, but it turned out to be pretty popular and get pretty popular pretty quickly. So we had
How
to
long
really.
was it? What kind of time frame?
We had 1,000 users sign up within the first week.
Wow.
And so it happened fast. Within the first few weeks after announcing it, we were running into scaling problems.
Wow.
So fast. It happened fast.
Did you already have a large network of people you knew? I know Chris Coyier has a lot of followers on Twitter now. He's very well known and respected in the community as well. Did you guys already have that kind of network, or was it just you put this out there, people noticed it, and they really liked it and started using it?
I would say it was the former. Chris Coyier at the beginning of CodePen represented like 70% of our inbound traffic. If you looked at Google Analytics, he was our number one referrer by a huge margin. He already had this huge following. He already had a huge network, and so a tweet from him saying that he was starting a like JS Fiddle competitor was all it took. That happened really, really quickly.
That's so incredible. You can just write one tweet on Twitter, one post on Facebook, and boom, a project can just take off like that. That's awesome. Wild. You don't have to spend millions on advertising. It's fantastic.
Yeah, I mean, we're in a lucky position that Chris is who he is, but you're right. That's what's kind of amazing about software in general is if you have a good idea and you can get it out, on these like free platforms, it can suddenly become a thing. It's awesome.
I'm really happy for you guys, and there's no exaggeration when we say that it's become a very big success. Like I said in the introduction, you guys get 32 million page views a month, 3.2 million uniques a month. That's fantastic, and so. I want to take this application, I want to take the infrastructure, as I said, and peel off the different layers to talk about what kinds of problems you've run into. And you said you had some scaling issues in the beginning. How did you go from that one box, that one poorly configured box, to multiple different servers, and you're running Ruby and things like that. So I want to peel off the different layers. But first of all, I want to talk a little bit more about the CodePen service. And you guys have these, what you call pens. I call them sandboxes. I don't know if that's the correct term to use or not. I think I've seen that term used before, just because it's different forms that you can write things in it and you can see a result come out of it. But that seems like it's really resource intensive. I mean, you've got users typing things in. It's constantly going back and forth between servers, communicating with your backend services and things like that. What kinds of performance issues do you run into with your sandboxes or your pens?
So like performance issues for us has always been just, I guess in the beginning, the performance issues we ran into was simply the volume of requests coming in. We have an interesting problem at CodePen in that a regular web application request coming into a Ruby server is relatively quick. Unless you're writing really poorly configured queries, you're returning a response typically in milliseconds. Unfortunately, because of the way CodePen is set up, we're running, like you said, sandboxes. We do preprocessors, so things like Jade and Stylus and all these preprocessors, they tend to run slower than a normal web request would. There's a lot of overhead in setting up a preprocessor call, and there's a lot of time spent just getting a user's call returned to them. So you've got this interesting mix of like regular application calls, which return really quickly, and then you've got like a call to Haml, for example, can take at least 100 milliseconds. Like an average Haml call takes 100 milliseconds, and it's just because there's this weird startup penalty in running a preprocessor that was never meant to be run on a server. This is supposed to be a preprocessor is normally something a web developer runs locally on their application,
right,
like on their desktop, and it doesn't really matter if it's like slow, because it's not meant necessarily to be run as a server-side application. So for us, the big thing has always been preprocessors, and how do you make them fast, and how do you make them performant, and how do you like separate them from the rest of your application so you're not like pipelining slow calls or fast calls behind slow ones.
Mm-hmm. I mean, how do you optimize that? You can't really optimize preprocessors. They just, come the way they are, and you have to work with their limitations and things like that. So that sounds like a really big challenge, definitely.
Yeah, for us it definitely was, and moving stuff to services was kind of the answer to ensure that we're routing stuff properly, and we've got the the servers set up and dedicated to the different preprocessors, and we can definitely go into that.
Yeah, definitely. But first, there's another problem that I could see with these sandboxes, and that's security issues. You're letting people type and run code in the browser on your services. What kind of problems did you run into? Did you have any security issues, any scares, anything like that?
Yeah, security issues out the yin yang. We started, like I said, and ran this application on a single box, and about 3 weeks after setting the thing up, someone wrote in and they were like, "Hey, check out this pen," and it was a pen using a preprocessor called Haml, and it was basically spitting out the output of our HT password file in our application. And you're like, well,
nice. At least he told you.
Yeah, I mean, thank God for white hatters. Like most of the remote, I mean, I would say all of the remote execution bugs that have been found by guys who like found them with the best intentions. They might have been just poking around, and they're like, "Oh, hey, how about that? This is a security issue, or this is a bug," and they'll write in with it. We luckily so far haven't had anyone who's tried to do anything malicious with it. And like I said in the beginning, we didn't know what we were doing. This is all brand new to us, and it really, to me, I mean, when it came down to it, it was just a permissions issue. You obviously shouldn't run these preprocessor services in the context that can read important files like your HT password file or your database.yaml or something like that. So for us, it was just a wake-up call. At the time, the service was young and it was new, and we weren't storing anything privately, and so there was no real issue real issue other than like embarrassment that we had done something like this. But it was a wake-up call, and we're like, let's get this thing going. So yeah, that's the problem with running code in sandboxes is remote code execution. Haml and Slim run raw Ruby. If you say puts quote hi into your Haml code, if I'm looking at the output log for the server, it literally is like printing to standard out. And you have to find a way. That's benign, but you have to find a way to keep people from doing things like file.read and it basically anything that's dangerous. Backticks, for example, in Ruby will allow you to like drop into a subshell and literally run stuff on the server. So you really have to work to prevent that sort of stuff. File system access. So that is Haml and Slim. Stuff like SAS and SCSS allow a data URL, so you can like read off the disk if you want to. So for us, we run into all kinds of security issues, and it really has to do with preprocessors. That's the big problem. So for us, we've got like a whole. You had asked later on in the show. I guess we're going to be talking about how we secure those, and there's a whole laundry list of things that we do to make sure that we do.
Actually, we can talk a little bit more about that now if you want. And I was just going to say that a lot of times when we talk about scaling an app, it's not just about the requests per second. it's not just about the monitoring. You're going to have users that are going to use your service in a way that you never even imagined, as you just said, right? People trying to break it or trying to crack into it just because it's a challenge. They want to see if they can do it. They want to see if the person that built the service thought about all those things. It's a challenge. It's a give and take. And so that's another very important part in scaling an application. And so I know that you now run these sandboxes in Docker, right?
Correct.
And so from what I understand, you have one container per service.
Mm-hmm.
And I'm looking at your notes that you sent me here. You've got a read-only root system. You fork calls to protect instance variables, and you restrict number of file descriptors so that you can't shell out. Can you talk a little bit more about those security features that you can use in Docker and Linux?
Sure. Yeah. So like the one container per service, like basically for us was important because it gave process isolation. So if you break HAML, for example, you're also not breaking Slim or, SAS or SCSS. Essentially for us, like the beauty of Docker, I guess in general and specifically for us is that, you're running the concept behind Docker is you're running you've got a very small footprint. Your application itself inside of Docker is meant to be as minimal as possible. In our case, it really is like, probably 40 lines of code or something like that. Mm-hmm. It's a single web application that runs on Sinatra. And all it really does is just call HAML. Anything we need to do before that, we do in a separate service we call a router, basically. That's probably a poor name because it mixes up the networking concept of router. But like anything that we need to do security-wise, like strip out calls that shouldn't be made, that all happens separately. And the single instance of HAML we're talking about runs in a single container. So that's kind of the beauty of Docker, and it's perfect. It came along at just the right time. Docker does allow you to mount the file system as read-only. So if you did try and for example, our regex stripping before the call comes in was something important. If you were to try and write to the root file system, the operating system itself will reject that. You get an error. It's like, sorry, read-only file system or read-only root. We fork each call, so that the concept there is like right before the call is made, we ask Ruby to fork out, and that gives a separate process for each call, so that if someone did happen to break into the system level variables for the server itself, the whole copy on write semantics basically prevent anything dangerous from happening. You can edit, for example, the env variable, and it's not going to hurt anything because you've got your own little memory space there that you're working with. And then probably the biggest thing that we found recently is that we can literally turn the number of file descriptors down to 0. So that means that like when this web server starts up, the number of file descriptors that a single process, someone trying to run a single instance of HAML, is restricted. Like you cannot, for example, file.write. You cannot, for example, backtick to get out to the shell, because each and everything that you do in Unix is actually starts its own file descriptor. And by limiting the number of file descriptors you have, we're ensuring that you can't do anything outside of the Ruby process that you're in.
That makes sense. And by forking, that's when you take a service and you make a copy of it instead of changing directly on it, right? Is that what you're talking about, or are you talking about specifically? Okay.
Yeah, that's exactly it. Yeah, we're if you can think of at the operating system level, if you were to make a long running call and put the ampersand behind it, you're basically saying run this in the background. That's the same concept here. We're literally forking each and every call out so that they're running outside of the context of the web server. It has the same memory to the software. It looks exactly the same, but from a protection standpoint, you can't actually edit variables on the server itself.
Mm-hmm. Let's talk a little bit more about Docker, and then we'll move back to AWS. But the reason I want to talk about Docker is because, as you said earlier, you started out with Vagrant. You use Vagrant. I use Vagrant every day. I still do today. What makes it different than Docker? Or what's the difference between the two?
Yeah, so for me, I guess the difference I see, they both run, you're both conceptually you're starting a server in either one of them, right? You're starting a VM with Vagrant, and in And in Docker, you're starting a Linux container. So the difference really is semantic. When you start a Docker container to the operating system, it looks the same. There's the normal set of files that an operating system expects to be there, except they're running. Those files are actually like recreated in a little file system that is segmented from the host.
Okay.
Whereas Vagrant itself, like each and every time you start Vagrant, you're literally starting up a new VM. And so the difference for me, the difference I see from a like everyday development standpoint is the speed at which you can start something up. For me, Docker containers are pretty cool because if you want to mess around with this, if you don't know how the sudoers file works, for example, you can dig around in there, play with the sudoers file, see how that works, like see how that affects the other users in the application. And if you mess that up and lock yourself out of the system, it's no big deal. You stop that container and restart it, and you can do that in seconds. Whereas for me, with Vagrant, the problem I see is that if you're messing around with the sudoers file, you lock yourself out and don't allow root access again. You have to stop that. VM and restart it. And the startup penalty to me was pretty high. Like you're basically reconfiguring the application all over again.
Another good point with Docker that I could see is that you've always got the same thing. You've got the exact same box. And so you can distribute that to all the different servers, and you know that you're going to have the exact same configurations and all that. And Vagrant kind of does that in a sense as well, but I feel like it's maybe a little bit harder to achieve that end result.
So, I mean, they both achieve the same thing. I just feel like when you start a new Vagrant box, you can pull down an image, but ultimately you can't distribute a Vagrant image out to your applications. I guess that's the biggest difference between Vagrant and Docker, is that like that end result, that container that you've built, the image, I guess, that you've built, that thing literally can be distributed out to all your different servers. And when you start it there, it's exactly the same as it is on your desktop. Whereas Vagrant, you can practice setting up configuration scripts through Chef or Ansible or whatever, but you also have to run those scripts on your servers all over the place. So that's the big difference I see from an operational production standpoint. Yeah.
And if you have to make a change on Vagrant, you have to reprovision it. Whereas with Docker, you just destroy it and start over, right? You just boot up a new container.
Yeah, that's exactly it. Because of the union file system and the way stuff works like that, you kind of like cache these different layers. So if you're just changing one thing and you want to reprovision, all the steps before that have already been provisioned. So if you've got a Docker file that's 100 lines long and you change the 99th line, the first 99 lines are already cached. You don't have to reprovision or rerun those lines. It's just that last line that you're changing, and that's pretty powerful when it comes to like being iterative and moving at speed when you're practicing on your configuration setup.
Did you have any issues switching from Vagrant to Docker?
For me, it was just conceptual stuff, like there's a lot, just like anything else, in this world, there's a lot of edge cases and a lot of things that you need to understand before you can even do the most basic thing. Vagrant itself is pretty nice because when you start it up, it is what it is. It's a server and you use the normal tools. With Docker, it just seems like there are a lot of things that you have to understand up front, linked containers and volumes and all that sort of stuff. Even just understanding or grokking how that union file system works, that's, there's a conceptual change that has to happen in your mind. And to me, there's a high startup cost, I guess, for learning Docker. But once you learn it and you kind of understand the nuance, I think it's pretty powerful.
And in the notes here, I see that you also put networking and deployment as challenges. What do you mean by deployment? What's the challenge there with Docker?
Well, so I mean, there are things that are coming along. I guess this Docker Swarm and a couple of these newer things that help with orchestration and setup of your Docker containers. You can have a Docker container and it runs locally, but you still need to get it set up and run on your server.
Right,
so. Getting the images to your machines, and then I guess routing within the machine itself, if you've got several Docker containers, is more of a challenge because you're dealing with networking at a box level, whereas before, with AWS and with virtual machines, each machine represents its own little, I guess, works in a wider context. Within the VPC context is all you have to think about your networking. But with Docker, you have to think about your networking at the VPC level, and then you also have to think of it at the box level as well. If you have several containers, there's port management you need to deal with, and there's load balancing as you start new servers. For example, one of the Vagrant scripts that I can talk about later that we use for deployment of Docker containers, you'll start a Docker container that runs side by side with your other one. You run a systems check to make sure that Docker container is up and is answering calls, and only then do you take down the currently running, like if you're talking A, B, and A is your master, you don't start B until you're sure that B is working. And once B is working, you take down A.
That makes sense.
So yeah, there are definitely some challenges and some things that you have to think about. They're all problems. It's just where are you going to focus your energy, and where do you think those problems are going to be?
And it seems like Docker has really grown in size as far as community goes. Compared to something like Vagrant, I feel like Vagrant has a really big community. It's been used by a lot of people. Has there been any difference in that?
To me, it just seems so bleeding edge that sometimes finding something that works, I guess solutions could be posted that are 3 months old and are already outdated. So finding the most recent information sometimes is a bit of a challenge, but also there are just so many people that are so in love with the concept of Docker, and there are so many evangelists for it that I haven't found it to be any more challenging than Vagrant was to learn. But then again, I started Vagrant with zero knowledge of computer server infrastructure management, and I'm coming into this with a lot that part has already been understood by me. Now it's just understanding the nuances of Docker within that environment. So yeah, maybe it has to do with my sophistication at this point. Not to say I'm super sophisticated, but I guess I've leveled up at this point, and so now it's just understanding Docker, not trying to understand how servers work in general.
Another technology that you swapped out is Chef. Went back to your blog. It's boom, boom, boom biz. If anybody wants to check it out, there's a few articles about Chef and Vagrant and Capistrano and all those. Very interesting to read through. But you used to use Chef quite extensively from the looks of it. Now you switched to Ansible, right?
Right. Yeah, we're using Ansible now, and we switched mostly, I guess, for. We switched mostly for, I guess here's the deal. I feel that Chef is a little bit loaded, a little bit complicated. It's a great system, but trying to explain to someone how it works up front is very, very, there are a lot of moving parts, from Chef server to the Chef client, and Chef solo, and then all the deals. Working with environment variables is kind of interesting, and precedents and all that sort of stuff. Explaining that to someone and getting someone up and running and getting them to understand just the basic Chef ecosystem is that's pretty challenging. Whereas with Ansible, someone can run an Ansible playbook and immediately see what it does, because there's this push rather than pull model is really easy for someone to understand. You don't have to worry about setting up clients and omnibus installations and all this sort of stuff. It is what it is. You've got a server and it pushes out some what appears to be really simple YAML scripts, and that's it.
What do you use Ansible for?
For us, we use it mostly for gluing stuff together. I would say the biggest thing is deployment. We use Ansible for the different types of deployments that we do. We use it in two ways, basically to push up application code, and then also for server provisioning is the second way. So that meaning when a new server comes online, the first thing it does is run a bunch of Ansible pull roles or Ansible pull playbooks, and that gets the server into its the state that you want it to be in, and then after it's in that state, then you pull down the sort of bundle of code that you've got. You put the bundle of code in place, and once with those two things, with the configuration and with the code, your server is ready and up and online.
And do you still use Capistrano at all?
Yeah, I mean, but not as much. Like, I've got one service that's really simple, the Sidekick service that runs on
Yeah, okay.
A Ruby, a Ruby on Rails app, and we use Capistrano because it's, why change it? It works perfectly. There's nothing fancy that we're doing with that deployment. We're literally just doing a git pull and then a precompile and then push. And there's a single server and there's nothing dynamic about the situation. It's literally a hard coded DNS name. So no, there's not much to do. So Capistrano fits the bill perfectly for that.
Hmm. And you use all that for queuing, right?
Yeah, just the Capistrano to push our queuing system.
Queuing
correct.
system. Okay. What do you queue, or what do you use queuing for?
Gosh, we queued lots of stuff. One of the things that we do every time someone saves a pen, we take a screenshot of the final result of that pen so that we can use images throughout the site. People like to post, for example,
Okay.
If they tweet out their pen, we have a screenshot that's ready to show up as a Twitter card so that they're not just tweeting text, they're also tweeting like an image of their final creation. That's one of just, many things that we do. We use it for not only like offloading that heavyweight pieces like that, because we do actually like queuing, for example, of this thing. We don't take a screenshot every time we save. We take a screenshot every 3 minutes of all the pens that have changed in those 3 minutes. So that means that if you saved 20 times your pen in those 3 minutes, we're only going to take one screenshot. And so what we do is we put this thing out into a Redis set that says, these are the pens that have changed. And if you save 20 times, it's only the pen that you want screenshotted is only going to be placed in that set one time. Mm-hmm. So yeah, we use it for that. We use it for scheduling. There's all kinds of like cron type jobs that run in the background. So we once every 4 hours, for example, we'll queue up some like spam type stuff, and every few minutes we'll just do a different task. So queuing is pretty important for us, but it's also pretty simple. We just anything that's going to like hold up the call for the user gets queued.
Mm-hmm. That's not critical for that moment.
Right.
You can put it in the background. Mm-hmm.
Yep.
Saves a lot of time. All right, so now we know about the sandboxes. We know about how you deploy Ansible, Docker. But we haven't talked about AWS yet, which is what really, really interests me. More specifically, your infrastructure. So can you share the stats of how many web servers you have, load balancers, the machines you're using? I think you're using M3s, is that right? For at least most services, like web apps and the preprocessor.
Yeah, the preprocessors, we're using M3 larges for those at the moment. So yeah, I'll dive into that real quick. I got a pretty long list of that stuff.
Awesome.
CodePen runs in around 25 servers. From a web server perspective, it's like 4 M3 larges for the main application, and then 3 M3 larges for the preprocessors.
Is that just the better performance that you've had for the price, or is it because of the memory? Or
yeah, for memory, it's the best balance for us of like CPU and memory. Because
I think they have pretty good networking too, right?
Yeah, the networking is, it's interesting. They always state that, like, it's funny. They give you no actual numbers. They're like,
I think it fluctuates. Yeah.
Right. They're like good, better, and best. I don't know how to put that into context when we're talking about network requests, but I can tell you that we never have saturated the NICs on these machines. So I'm assuming the networking is great for the M3 large. For us, it was just the right balance of CPU cores and memory.
Gotcha.
We use those. What the languages that we use, I guess, are Ruby and Node, and so we run Ruby and Node on those M3 larges. They're a Ruby on Rails app, and then the 4 M3 larges for the web apps are Ruby on Rails, and then the preprocessors on the T2 smalls. Like we've got a number of those that sort of like do different pre-processing tasks. So we've got three T2 smalls running like the very isolated things like Haml and Slim, the ones that are absolutely dangerous. And then three M3 larges with a bunch of Docker containers running the preprocessor servers themselves with the Docker containers. We use three M3 extra large SQL boxes. We've got a master slave setup for that, your standard replication. And then we've got a third box that we use like as our export box. We have the ability, I guess, because CodePen's getting pretty large. It's not huge in terms of, databases, but it is 40 gigs. So if you want a backup of the database itself, we needed to figure out a way to sort of pare that down. So we have this export process that allows you to specify basically a collection of users that you want to pull the pens down for, and then all of the like most common things, like all of the picked pens and all of the like maybe 1,000 of the most recent pens. So we have like an approximation of what's running on production, but the difference is we can pull down and export in under a gig. Whereas like if you were to pull the whole DB with every single pen, you're looking at 40 gigs, and the process to get it down, like get it built, pull it down, and run it on your machine is just it's outrageous. It could take like 4 hours for that MySQL dump to pull in. So we need to be a little more agile than that. We run R3 larges for the Solr in master slave, and then we run
for searching.
Yeah, mostly for. I mean, Solr is a search server, so that's all we use it for.
Okay.
But we use it in some pretty unique ways. Solr is pretty interesting because the search capabilities are great for the user-facing stuff. Like I want to search for a pen that contains the words Tim in it. But also we can use it we use it pretty intensely in the back end for spam prevention, because a lot of people are trying to basically put their, LAMP store needs to be online. And so they're told by their SEO specialists that the more backlinks that they have, the better off they are. So no, people are constantly trying to put spam on our on CodePen. So it's pretty interesting. Every pen gets indexed, and then we have this gigantic list, that you would never show your mom because it contains a lot of naughty words in it. And that list gets run against our Solr box. The Solr box returns possible spam pens, and then manually we have to go through and delete those accounts so that people aren't continuing to do that. So yeah, Solr is being used there, and then we use Redis. We've got two M3 larges that we run in a master-slave configuration.
I know AWS has the Elasticache, which is supposed to be specifically for Redis or Memcached. Why are you using an M3 instead? Is it just cheaper? Or?
Well, for us, we needed... if we wanted to run... The problem is, I guess, for us, is we have... Redis has the concept of DBs. I think you start out with 16 DBs by default. We use 4 different DBs inside of Redis, for different levels of caching. We've got a volatile cache. We've got a permanent cache, stuff that we absolutely won't get rid of, like counts and things like that. We have another DB for queuing, and then a fourth one for something else I can't remember. So for us, if we were to do master-slave configuration for each and every one of those, we'd end up with, 8 boxes, and that's just not something that we... it's cost prohibitive for us to do that, because the Elasticache won't allow you to have multiple DBs. So each one of those caching instances would only host 1 DB. So with our 4 DB constraint, we would end up in a place where we're running 8 servers, and that just seems untenable. Yeah. So M3 largest master slave. Awesome. Nice. High five. And then we've got a bunch of
easier too. You've got everything, or almost everything, on M3 larges, or the bulk of it at least. So that does seem to make it easier as well.
Yeah. I think of those. I think of the box type or box size as almost irrelevant. We never think of the cost of the thing. We just think mostly of what works best with our application. I mean, obviously cost is a factor, but it's we're choosing these application servers because they fit the memory profile, for example. We were running the Solr boxes on medium-sized instances about a month ago, and what we found out is that the corpus, like the size of our index, was around 11 gigs, and the memory ceiling that we had on that box was 3 gigs, and we would have these like slowdowns that would happen every hour or so, and we for a while couldn't figure out what it was, and ultimately it came down to the fact that if you run Solr, they say your corpus has to fit in memory. And so once we realized that was the case, we upgraded to R3 larges, and boom, these slowdowns are absolutely gone. Everything runs swimmingly and fast.
What are some other painful parts of your infrastructure that you've had to deal with?
For
I know
us,
that's a pretty big question, but
yeah, I mean, the way I think about it, it's like every part of this infrastructure has been painful at some point. It just depends on like what time period you're talking about. If in the inception, like everything was a problem. When we started, it was all on one box, and so we had this big ball of mud. We had no monitoring, and literally everything would fail. We would blow the memory out, we would blow the CPU out, and there was no way to tell why that was happening. So in the beginning, it was like the most painful part of the infrastructure was the infrastructure. But as we continued to like move servers out, and like as CodePen began to make a little bit of money, we were able to afford to like basically isolate different parts of the infrastructure so that we could better understand what the memory or CPU profile for each one of these were. So for example, when we had deployment slowdowns, we would move the deployment box to we would move the deployment process out to a separate box, and it would have a faster disk, for example, for doing the pre-compilation. Or we use turbo sprockets to speed that up. We would buy bigger boxes ultimately for the web servers, and we could better tune Fusion Passenger to handle the number of CPU or memory constraints that we had there. We moved the storage stack out ultimately to its own set of boxes. The MySQL boxes started running on their own stack. Like once we realized that we were having problems with memory in sharing Redis and the DB together. We moved Git into GitLab. We moved from GitHub to like an internal GitLab server, and that scaled improperly at times because we didn't have the correct size box. We've had issues with Solr in the past. Like I said, Solr, we didn't understand our memory constraints for the corpus size, and that too has caused some issues. So like, I don't know, just talk to me at any point in the last 3 years of running CodePen, and I can tell you there's some painful part of the infrastructure that's pinching us, and you just have to address it at the time.
Is there one specific one right now that you're having to deal with at this specific
we
moment?
We just did that Solr thing, so that was the big thing. I'm like breathing a sigh of relief at the moment that that's working. I guess one of the interesting parts about that, and you should never do this, and we realize this, in most cases our services are loosely coupled. If you have a long running process, if you have to make a web request, you typically want that to run in the background, for example. With Solr, we found that we were like, the web app itself was tied not from the indexing standpoint, like each and every time we would index something, we would queue that and ask it to index in a little bit. But the problem we ran into, and we didn't realize we ran into until years of running Solr, is that we were tightly coupled from a query perspective. So if you were to, for example, we were getting, it wasn't super heavy traffic, but like 10 queries a second or something like that. And what we found is if the query server went down, or was slow, our web application itself was directly tied to that. So if Solr was to fall over, so would our entire web application. So what we ended up doing was like using Redis in front of each call, and we basically say, hey, Redis, is the server up for search? And you ask that every single time before you make the HTTP call. If enough of the web requests report that the Solr server is down, we'll basically redirect you to like a fail whale page that says, hey, Solr will be up in a moment. And, we time the key out that's in Redis that says that Solr's down to like, I can't remember, it's like 30 seconds or something like that. Okay. So after 30 seconds has passed, that key gets erased from Redis, and then the same thing happens again. The boxes start asking, hey, is Solr up? And if Solr's up, then everything's cool. If we have that key that says it's down, then we we kind of decouple ourselves from the problems that a slow service could cause.
How do you use Redis to do that?
So
You just
yeah, so like basically we set a Redis key that says we basically before each call we ask Redis, hey, is is Solr, is the search server up?
But how do you do that? How do you check to see if it's up or not?
Oh, just basically if we write a rescue call around the
I see.
HTTP call. If the HTTP call fails, it sets a Redis is down flag in Redis the first time that happens, and then we use Redis increment, and every time we get one of these downed calls, we increment that counter. And if the counter reaches a certain threshold, I think right now it's like if we have 15 failed calls in 5 seconds, Redis itself will report that Solr is down. And so we no longer make that call. We basically say for the next 30 seconds, don't make any calls at all to Solr. And then once that key expires, we then like allow those calls to go through. If they fail again, we key that Redis key and just move forward like that.
I love Redis. It's great.
Yeah. Oh God, it's so amazing. I was just looking at it for this interview. The thing processes 1,000 requests a second. It's just like absolutely stunning. It was like 82 billion calls have been made in the last 152 days. It's like absolutely insane. The traffic that you can throw at Redis and how it'll just like stand up to it all day long. It's amazing.
It's funny. I did a screencast on Redis configuration talking about the database, where it saves, how often it saves, things like that. And I remember reading in the documentation the security part, where if you're on a shared hosting environment or something like that, you may want to add a password, right? But the problem is your password needs to be extremely long and strong, because it can handle something like 150,000 tries a second or something ridiculous like that.
Sure.
So how do you protect against brute force, right? It has to be an insane password.
Yeah, absolutely. So yeah, Redis is just an amazing piece of software, and that's testament to it for sure.
And I want to talk a little bit more about Redis in a second, but since we're talking about issues with Solr, for example, and how you report an error with that, how do you do that if you lose a web server or a load balancer? If something in your infrastructure just goes down for whatever reason, how do you handle that failure?
For us, we use AWS autoscaling, but we use it mostly for like disaster recovery. We do have the ability to so I guess let me back up and explain what I mean by that. Each and every web server is sort of like self-healing. If the web server, like through autoscaling, you can tell Amazon, if this server goes down, take it out of the load balancer and bring another one up that's exactly like it. So in our case, we use the autoscaling stuff to say, if a server comes down, we basically treat the servers like cattle. We can kill them off if we need to, because there's always more cattle, right? So if a web server starts misbehaving, we'll just let it fail, and autoscaling will bring in one that's exactly like that. So yeah, we use it for we use autoscaling to kind of prevent that.
And let's say you want to change a web server out. Here I see you set up load balancing to replace it out. Is that how you do it?
For us, if we want to change a server out, I guess it depends on what you're talking about. For code deployments, we just use Fusion Passenger and push up new. We push up new code, and Fusion Passenger at the process level handles that. You touch a restart.txt file, and it starts up a bunch of new processes, starts routing calls to those new processes. If they don't fail, it takes down the old processes, and that's, from a code deployment standpoint, that's the way it works. For web server changes, like if we're changing from an M3 medium to an M3 large, we do it either at the load balance level, if it's a load balance service, or at the DNS level, if it's a single box. And then for like super time sensitive stuff, we'll use like this concept that I just started working with, which is like the idea of a VIP, or a virtual IP. Which is pretty cool. You can basically in AWS assign a secondary IP to any box that you want to. And then inside the box itself, you can configure the network configuration to say, I will also accept web requests on this IP address. And what that allows you to do is float that IP address around to different servers. So at the AWS level, at the control plane level, you can suddenly switch the IP address from box A to box B, and it's instantaneous. Whereas with DNS, you have to wait for DNS propagation and time to live and all that kind of stuff. With a VIP, and you can only do this in the VPC, by the way, but with a VIP, you can do it like instantaneously. So for data loss, time-sensitive type stuff, like failing over from master slave in Redis or in MySQL, the VIP is the way to go for us. So it kind of just depends on like the level of granularity and the severity if you had data loss, how you change out servers. And there's a whole bevy of ways of dealing with that.
Sure, and you actually had an outage back in March of this year, which was with DNS, AWS DNS. Can you talk a little bit more about what happened there?
Yeah, so DNS just went down, and we don't know why. And Amazon wasn't super clear about it. They did say in their outage page that they were having trouble with DNS, with slow DNS resolution.
Helpful.
Yeah. So it basically stopped our application cold. Your applications are trying to say hit db.codepen.io, but db.codepen.io is not resolving. It's timing out. So 20 seconds is going by for each and every DB call, and obviously your servers are going to fall over.
Yeah. How do you avoid that in the future?
We could use, for us, multi-AZ would probably be the solution. That is to say, if DNS isn't failing in the other availability zone.
Right.
You could use raw IPs, I guess, if you really wanted to, but I definitely wouldn't suggest that because the DNS system is so nice. And in our years of working with AWS, we've never had this problem before. But I guess mostly you just like multi-AZ is supposed to solve that because they do conceptually have different DNS boxes running for each AZ. So that's something we hope to move to very soon. We're waiting on RDS. Like we've got a contract with Percona right now to move us off of raw boxes and into RDS for our DB servers. And once we do that, I think we'll have more flexibility in getting into the multi-AZ type of thing because the database then will be able to fail over from one availability zone to the other. At the moment, we don't have that. We don't have multi-AZ because we don't have a sophisticated enough database system to do AZ failover.
And this is definitely not the first time people have had problems with DNS, with DDoS attacks and things like that.
Yeah.
There's all kinds of stories about that, so...
It is what it is.
Yeah,
it's the most. This is the system we got, and I love it. But yeah, there are occasionally blips and outages.
Mm-hmm. Definitely. So you do use Percona right now?
We don't use Percona builds, but we've contracted Percona.
Okay.
We're buying. They call it a 3-day engagement. So for 3 days, they're basically gonna. We bought 24 hours of their time, and they're going to basically help us forklift these boxes off of raw AWS instances and move them onto RDS. So we're using Percona, the consultancy, not Percona, the application or the plugin system for the DB.
Mm-hmm. All right, let's start wrapping up with Redis. One of my favorite topics. I've had a lot of screencasts about it. I just like using Redis. It's for a lot of use cases, it's just the best way of going about it. It helps save a lot of traffic to your database and things like that. So it's definitely a very nice service to use. I'm looking over your stats right now, and as you were saying earlier, these are pretty incredible. Let's see, 11 billion calls in the last 153 days.
Yeah, it's crazy.
1,000 plus requests per second. 2 gigs with 3.7 gig peak. That's incredible.
Yeah.
Have you gone through Redis configurations and changed any of the default ones, or have you just left the default and let it play by itself?
Default didn't work for us. We didn't make that great a change, but on the master, we basically don't do disk syncs. Like we don't write to the disk at all. We've turned off I don't recall what that's called, but the problem we ran into was that the velocity at which the keys were changing were causing these background saves to be running almost constantly. Mm-hmm. So what we did was on our master, we've turned that off, and on the slave we have a high IOPS disk that runs, and the machine itself is EBS optimized so that we can like very, very quickly write out the what type of file is it? RDF, I think.
RDS, I believe. Or no, RDB. RDB.
Yeah, RDB. We can like rapidly write out the RDB file, and we've tuned it in such a way so that those calls, like the defaults, basically would have us saving to the disk constantly. So we turned the velocity settings, I guess, up much higher. Like there's a much higher threshold before we save that file out to the disk.
Do you handle, because here I see that you have volatile and non-volatile, do you handle those differently? Like, do you just set a timeout for the non-volatile and then just don't have a timeout at all for the volatile ones? Or do you change the way it saves?
We don't change anything about the way it saves. Like, essentially, we use the volatile storage for like your basic caching. On the home page, we don't want to pre-process, for example, every single pen that's on the home page, because that itself would like bring CodePen to its knees. The very first time the preprocessor happens, we cache out the end result to Redis. And so we treat the volatile stuff basically like memcache. We set a timeout on it, and every 15 minutes or so, we'll like or on pen change, we'll like we'll kill that key and allow the call to go through to the preprocessors. For non-volatile stuff, persistent storage, we store all of our counts in persistent storage. We at the moment don't store counts at all out to the DB because they're just not. They change so rapidly. It does. I would say that that's probably not our favorite way of setting stuff up. We have some code that's written right now that just hasn't been put into production that like uses MySQL as a backing for the counts, because if we were to lose our Redis instance and also lose our backup, we would also lose all the counts for all the pens that have ever happened inside of CodePen. And that's so in that sense, we kind of have to treat Redis like a pet. We have to be very, very careful with what we do to it. You definitely can't wipe out the non-volatile cache. And then also we need to make sure that we're storing backups of the RDB file.
How do you store backups of RDB files?
We just push them up to S3. It's pretty simple. The file itself gets written out to disk, and then that file on an hourly basis gets written up to S3. So if there ever were an outage and it were catastrophic, we would lose counts for an hour back. And we don't see that as like the world's worst thing. But we're also not, we wouldn't want that to happen. So we just kind of treat Redis very specially. Don't mess with it.
Sure, and it depends a lot on your application too. In your case, you're fine with losing an hour. Maybe somebody else has a different application that they can't lose more than a minute or so. So that that's on a per use case basis. But that's always interesting I like to ask that question.
Sure, yeah. I mean, it just depends, like you said, on the application use case.
Yeah. Mm-hmm. What are the data types that you use most often? Is it hashes, sorted sets?
Basically, I mean, we use Redis for the most part, like a key value store. You put in a key and you store a value at the end of that key. We use some sorted sets for some things, like I touched on the idea that we screenshot every 3 minutes. Mm-hmm. So we'll put stuff into a set and just make sure that set is unique so that we're not screenshotting the same pen over and over again. Mm-hmm. We use like a Z-add on popularity scores we use Z-add on sets for popularity scores so that we've always got like a sorted set based on a certain score. So every time someone saves a pen, we like take a look at the number of hearts and the number of comments and the number of the number of hearts and the number of comments. And also we have a score for age in there. And then we store that out into a sorted set inside of Redis so that it's very easy for us to pull up popularity for all pens basically on the site, pens and posts and users and all that sort of stuff.
Mm-hmm. Did you use Redis from the beginning? The application?
Yeah, we did. We've never used any other caching service. We used memcached at Wufoo. It was fine, but it's just like it's so much more sophisticated. The idea that you have all these different object types that you can work with, that's pretty powerful. So we've talked about using Redis as a least recently used cache, like LRU. and we just haven't done that yet. That would allow us to like not have to set keys, or I'm sorry, expires on keys, and you could treat sort of like you could just let memory pressure push the most recently used item out of the cache itself. That's on our laundry list of things to do, but it would require standing up another Redis instance, and we just haven't gone there yet. So for the moment, we use timeouts instead of memory pressure to handle that.
Just for anyone interested in more detail about LRU and Redis configurations, I just recently released or published this screencast on YouTube, I think maybe 2-3 days ago, where I talk a little bit more about that. And if you're confused about the concept or if you want to learn more about it, definitely check that out. Now, I know that you use master-slave configuration right now. I didn't touch on that in the episode because I figured it'd go a little bit too long. But can you talk a little bit about the process of setting that up and why you set that up?
Yeah, I mean, the process is incredibly simple, especially if you compare it to setting up master-slave replication for MySQL or any other database. I mean, it literally, on the slave, you say, I want to be a slave of this master, and you point it to a DNS name, and that's it. It just like the master ships over that RDB file, and the slave runs it, and then after that, every single call goes from the master to the slave. Super simple, really easy to set up. And for us, we use it mostly as disaster recovery. I know some people will use slaves, for example, as like read slaves. So you're doing writes on one thing, and then you can farm out the reads to different Redis instances. But we basically use it for disaster recovery, and that's it.
How long do you think this configuration will last for you guys? I mean, I know you have a lot of volume, but you say you don't have enough yet to use something like clustering in Redis. How long do you think you can use something like this? How far does it scale?
That is a good question. I read somewhere that they would Instagram would duplicate 20% more of their calls so that they knew when they were running into the headroom. They would literally overcall their boxes on purpose so that they knew when they started to hit the headroom that they could turn that off and then try and figure out a different solution. For us, I have no idea. The CPU sits at nothing on this box. The only thing we have to think about is the memory ceiling. But for us, I think we peak at like 3.5 gigs or something like that, and 2 gigs is about normal. So we have that on a 7 gig box for double the peak headroom, and who knows? I don't really know. But what I do know is that working with Redis is so incredibly simple that if we wanted to set up clustering, it really is like a couple configuration changes and you're good to go. I can't tell you how much I really like that software. It's incredible.
And I know that you plan on setting up Sentinel at some point in time. Yeah. Have you read up on that at all? Is that also another simple thing to set up?
I've been watching it. I've been watching Sentinel when it was just sort of like this beta release. I know in Redis, the newest version of Redis, they're like basically saying Sentinel's ready for production. Yeah. I think it's like incredibly smart. We just haven't had the time to set it up yet. As it stands, if we had an outage on Redis, we would basically have to like repoint our applications over to the slave and turn slave syncing, like turn read only off on the slave. It's a very manual set of steps. If we were to use Sentinel takes care of that master-slave failover for you, and I think that'd be pretty cool. We just haven't done it yet.
Well, Tim, we're running out of time here. I've got so many more questions I want to ask you, but unfortunately, I can't keep you forever. So, is there anything else that you want to add, or that you think we skipped over, maybe, or that would be interesting?
No, I think we covered plenty. I agree. I could talk about this stuff all day. It's super fun. But we got an hour, so we're going to spend an hour.
Yep. Well, I've had a lot of fun preparing this interview with you. I could tell you're really motivated to do this interview, and I knew this was going to be a really great interview. So I really appreciate you taking the time to do this with us. If people have any questions for you, or if they want to get in touch, how do you recommend they get in touch?
They can write to me at tim@codepen.io if they want a private conversation. If I'm at Tim Sabat on Twitter, and then you can always write into support@codepen.io if you wanted to reach any of us to ask us general questions. So that's how you do it.
Do you do a lot of reading, like books reading or blog reading? Do you have any recommendations for people if they want to catch up to some of the things you talked about today?
What is that? What is the most recent? There is a book that I read recently that literally saved our bacon. It was the one that dealt with file descriptors. Let me pull that up for a second.
Sure. If you can't find it, I can edit up later. But
yeah, maybe we'll put it in the show notes. It's
sure.
like Unix process modeling or something like that. I can't recall what it is. It's like it's very much wonkery. It deals with on a very low level with processes in Unix, but it blew me away. It was so incredibly great. And it gave us the key to what we needed. And then Hacker News. I read Hacker News as an addiction. It's so to the point where I won't turn it on at work. I will not allow myself. Rescue Time will yell at me if I turn on Hacker News during the daytime. So yeah, I guess just any old random books. I can pull up the most recent ones and we can put them in the show notes or something like that.
Another recommendation I have for all of you listening and watching is to check out Tim's blog. I said Boom Boom Biz. I think that one, you don't really post to that one as much anymore, right? You post on the CodePen one instead?
Yeah, so if you just go to my username on CodePen, so I'm tsabbat on CodePen, there'll be a link you can click on. I think the path is codepen.io/tsabbat/blog. But yeah, I've been writing more on that just because we started this blogging platform and we think it's pretty cool, and I may as well dog food our stuff. I've definitely when I committed to writing there instead of on my own blog, I definitely found problems immediately that I wanted fixed. I'm like, we need syntax highlighting for bash scripts, and we dog fooded it and it worked out pretty well.
Awesome. Another thing I'm going to link up below the video is a link to Tim's GitHub account. I was scanning through it last night, and there's some default configurations for Nginx and some other services as well. Can't remember all of them, but really good stuff. So check out Tim's work. Tim, thank you so much for doing this. Everyone, please leave comments below and let Tim know how this interview helped you out. Thank you all for watching. I hope you have a fantastic day.
Thanks a lot.
Until next time.